Good morning, everyone. Yes, reality modeling. I'm going to explain what that means very shortly and talk about the next chapter. So I think for a long time, thousands of years, we've been very good at taking ideas, abstractions in the forms of thoughts or drawings or models of some kind and then make them into reality and building them. And that's a lot of what we do, certainly in the AEC world. And what I'm interested in is how do we go the other way? Because if we think about a lot of the AR and VR uses, I mean, much of what's been shown is about new designs and thoughts and structures. What we should also think about is how do we do that with existing structures? And why would you want to do that? Well, maybe I want to manage a plant that's in China from here, but I'd like that kind of experience in that environment with something which feels very real, or any other sort of remote access to a space. And we can only do that if we have a means of capturing reality in some way and bringing it into the virtual world. So yeah, there's ways of doing this. Canaletto did a pretty good job, but I don't think he was thinking of managing infrastructure when he painted that, and it's not a very efficient way of doing it. And photography, of course, is a bit faster, and we've been doing that for a long time, using photographs to help us understand what a space is like, what a structure is like remotely, but it's two-dimensional. Now, more astute observer may notice this is the British Library, and which is not the British Museum, and you really shouldn't get too confused at 9 a.m. this morning. I'm trying to get here. Sorry, Martin, for putting you through that stress, by the way. So reality modeling from Bentley's perspective is really about capturing existing conditions, and it's only reality modeling if you're doing it in 3D. So we're going beyond photography. But what's really important is using one or a combination of devices. I'm going to talk a lot about that. And the idea is that we do it in such a way and we receive data such that we can really fuel and drive applications in mapping, in construction, in design, inspection, asset management, and so on. And it can be at any scale. So we're able to do this at entire city scale fairly efficiently, as we see here, down to small, and I'm afraid a lot of my examples are industrial because that's just the nature of a lot of the environments that we deal with, but it's just as applicable in more pretty environments. So this is an industrial plant or a construction site or a mining site. I mean, the ability to capture that in some way and bring it into the virtual world is very useful. And it's useful because we can use that information for design. We can use it for understanding existing conditions in a way that we've always done. I used to work for an architect, and we had a scrapbook full of photographs, and that was our means of understanding the site that we were working in. But today we can do that with a lot more detail, a lot more precisely, and in full 3 dimensions, importantly. And that really helps to mitigate a lot of design risk. And then in construction, construction is part of the life cycle which is perhaps lagging behind the most, in that it fundamentally hasn't really changed for, I don't want to put the number of years on, but I mean, it's construction in terms of the way in which design and operations have benefited from digital revolution, from technology. Construction really hasn't. And so providing greater visibility into construction is a real interesting potential of this technology. And then all the way through to management of assets, to training, visual operations, and so on. When you have a model which looks very realistic and has been captured from a site, all the way to virtual inspection. Your inspection is one of the most dangerous jobs or activities. I believe the highest number of fatalities happen in the US, at least, inspecting telecom towers. So being able to do that remotely is something which I'm going to talk about. So for those that so far, and forgive me if that's the case, really have no idea what I'm talking about, this is a great little demonstration. What we're doing, well, much of what I'm showing here actually comes from photography. It comes from taking photographs and using photogrammetry to build a 3D model. And there's a really interesting advantage to that. One is it's it's really cheap because you're just using a camera. You can even use a camera that's on your smartphone and it does work. But to get great results, you use a high-end camera. But we're now talking about a few £1,000s. And if you can mount that on a drone, then you get vantage point across a whole site, across the whole building in a way that's just been impossible before. And using that photography and algorithms and software, we can use that to build a full, really rich, detailed 3D model. What we're looking at here is a 3D model, and this is just a simulation around it. It's not a flat photograph. It's a three-dimensional 3D model. And that's allowing us to capture large infrastructure assets in the way that's just been impossible before. We have been using laser scanning, so it's not entirely been impossible, but it's been impossible to do it so cheaply, so often, because it's cheap and it's easy to get that data and capture that data. It just hasn't been possible to do that before, and that really opens up new possibilities for what's going to be doable with VR, and new environments in which you'll be able to use VR and AR. So, and it can be for survey or inspection. I talked about inspection before. So what laser scanning offered was the ability to remotely capture information in a way that previously you'd have to go out on site and use a tape measure or use a laser pointer, which made it a lot safer. If you imagine survey crew going out to a road, for example, that was always a dangerous operation. Being able to do it with a laser scanner provided both safety and also far more density in the information you got back. It was something comparable to what we have today in the way of big data as opposed to sampling. With scanning, we could collect data in a really big way. What we can do now with the drone is not only make the capture remote, but make the operation remote as well. The actual device itself has another degree of separation from the operator, and that gives a greater degree of safety, but it also gives this opportunity to access areas which would be previously impossible. Lovely movies, by the way. For construction, that's really big. We can now capture a whole construction site in a few hours, and that offers the opportunity to do it at a very frequent basis. The challenges are really around the software now. It's about where do you keep that data, how do you access it, how do you maintain it, but the ability to capture it and actually produce the model, which is what we're doing at Bentley, producing software that will generate that model from photography, is really something we've not had in the past. So what it's showing is we take a whole city model that we've captured from the air, and I think that one was with a helicopter and a high-end camera, capturing the city. And then not only can you get an idea of what that city layout is like and perform all sorts of operations in there, but in this case of a high-rise, we understand how light actually falls into that building, because we can place it exactly in context. We know which other buildings will affect it, and we can simulate not only we can simulate light as we could before, but now with a very accurate virtual environment. And now put that into VR, and it's an extraordinary experience. And what the movie shows is light coming into that building and then affecting that light with shutters, blinds, and so on, and how it responds throughout the day. And that guy is moving around, and then there's a firework display on the outside, and it is beautiful. But it really isn't about the different devices and the different technologies. And a lot of people get sort of bogged down into this discussion of how does it compare with laser scanning, what are the different. So this is all boring, I'm not going to talk about that. But what is really interesting to me, and where I think this is all going, there are two technologies. One is UAV, which I've been going on about for some time. The other is SLAM, which is nothing to do with the manner that you close the door, because that wouldn't really change anything. SLAM is the ability to know where you are in space by using image analysis or scan analysis and see how you're moving in the way that you can do today with GPS, and you can do on your phone when you're using Google Maps or something. But with SLAM, we can do this indoor. We don't need a connection to anything. We're just doing, I guess, in the way that our mind is figuring out where we are because we're analyzing the images that we're getting. We can now do that with an algorithm as well. And that opens up all sorts of possibilities of being able to map environments using handheld hardware, and I think you're going to hear more about that later, this particular device or a device on a trolley, just moving it around. And because it knows where it is, and it's taking photography and scans, it can then produce a map of that area, and that's really changing everything. But I do want to just address this point of how accurate and how useful photos can be in relation to laser scanning. And this was an interesting study done by Costain down at London Bridge, where I think they're demolishing all the old platforms and quite a substantial refurbishment. And this is under the arches. And these images, again, lovely three-dimensional, you can just imagine them moving, images produced with context capture using photography. But they really wanted to have confidence, because whilst they have laser scanners, and that was working well for them, they don't have enough for the 30 surveyors they have down there. And they're quite substantial things on a tripod. They have to move them around. And to be able to say, look, I really need a very fast scan of this pit because I have to make some decisions is something which is not always possible to do. So we did some analysis, or they did some analysis. They did their own analysis. And in the section there, in blue, you see the photogrammetry or the context capture results. And in red, we see the terrestrial laser scan, and we really see an excellent correspondence. So in an environment like this, it can work extremely well. And we were getting a deviation around 6 to 10 millimeters, making it very feasible to do that. But a lot of people have pitted these technologies against each other, and that's not really where I'm coming from. If we look at laser scanning, it's great in its accuracy. You could do it in a dark room. You can switch all the lights off, and you can scan a room. It's active laser. And you don't need any features, whereas photogrammetry does need features to work off. You get high density of intensity. You can do it in static in a continuous way, and absolutely not being patronizing to my Scottish co-presenter or previous presenter here, but it's a wee bit pricey. Whereas photogrammetry can be accurate if you do it well, but you need light. You can't do it in the dark. You'd be very disappointed if you try to do that. And you do need some kind of features for it to work off, but you get beautiful, rich, textured information, and it's easy and it's fast and it's relatively inexpensive. We really don't see these as being pitted against each other. It really is a perfect match between the two if you can use them together, and that's really what we've been focused on. How can we take all the different ways in which you can capture information from the mobile phone camera, smartphone camera, all the way through to high-end cameras to laser scanning, and combine that together. Because if we're not agnostic, there isn't many people in the industry that will be, because much of this technology is coming from various vendors of hardware. So this is a great example down on a rail track. That's what we get from photogrammetry, which you can see does an excellent result, but it does struggle with long, thin things because you don't get many pixels on them when you take photographs. And that's what we get from the laser scan, which is great, but doesn't look so pretty. And what we can do now is combine the two with a hybrid engine, which looks at both of them and gets the best from both. Tightens up the geometry that we get with photogrammetry and takes the accuracy that we get from laser scanning and puts it together. So this, to my mind, really is where I see the ability to produce reality models or do reality modeling going in the future. Different devices at different levels of precision, accuracy, cost points, being able to be used to produce data through the appropriate software technology that allows you to combine all of those together. And you can do it anywhere and take it anywhere. What he's doing is there is pipes, you can see that so much, and we have an app where you just take photographs, a bunch of photographs of that, and I think in this case it takes about 20. The data goes up to the cloud, we process it with the engine in the cloud and come back and you have a measurable, actionable model there. It's measurable if you've done it to scale with 2 points of reference. We then have a model, and that can then go into the project and be tagged. An inspector can use that to tag information and produce a report live on site with very little more than just a mobile phone. We can blend different scales. So this is a really interesting example of taking data from a drone, taking some laser scanning, taking a handheld camera and combining it all together. So we have imagery from the drone which captures the whole site. We have a laser scanner which is helping to tighten up a lot of the messy structure there which photogrammetry traditionally struggles with a little bit. And we have photography of various signage and specifications and so on. So you can zoom right in and read the signage on there and then tie that back to asset management information that's being pulled through and telling you about what those various assets are. So that is the future of reality modeling.